Here we are given the standard deviation from a study and a confidence level. What else? Let's see here. There's something I'm expecting to see that I'm not seeing right away. Okay, I see it now. All right, so people are asked about how many books they read the previous year. The sample standard deviation is 13.4, and we are given a margin of error of 6 books. We want to get that margin of error and have a 95% confidence level. Now, compared to some other things that were talked about, where we could not use the normal distributions, i.e. Z, we went to the T distributions. Well, unfortunately for us, we need to go back to Z here. Give me a moment. Got to think about what the reason why was. Be right back. All right, it came back to me pretty quickly. If we don't know the sample size, if that's what we're trying to find out, then we can't talk about the number of degrees of freedom. And so we can't look at a particular row in table 7. So we're going to be playing it conservative here by using a Z-score. All right, so partial table of critical values. For 95%, our critical Z value is 1.96. 1.96. And we're going to use this formula. So 1.96 plugged in for Z. 1.96 plugged in for Z. Our sample standard deviation was 13.4. And we're dividing that by the by the margin of error that they want us to have, which in this case is 6 books. Be within 6 books. You don't need a sign on the margin of error. That whole thing was being squared. You cannot have 0.16104711 of a subject. And furthermore, the rounding does not go in the standard way. It says round up to the nearest subject. Here's the reason why. If we put in the 1.96 times the standard deviation of 13.4 and divide by square root of 19, then you get a margin of error bigger than 6. We don't want to exceed that. It's a tolerance level. We want within 6 or less. So if we always round up when computing sample size, according to that formula, round up to the next integer, then we will get within the 6 that we wanted, or whatever the margin of error we're given. So that would round up to 20. Now I'm going to take a guess what they're going to ask on these other questions. Right about that. If we increase the confidence level, then we're going to need, I think it's fair to say, we'll want to combat a larger margin of error with a larger sample. What else? Whereas, let's see if I can explain that from the formula. So larger confidence level should give us a larger Z value. And I'm right about that. Larger confidence level, larger z-value. And that's if you're keeping the same standard deviation for the sample and the same margin of error, that's going to make that fraction larger. And so squaring it's going to be larger. Larger sample sizes coming from a higher confidence level. Changing your margin of error. If you divide by a smaller margin of error, which is what a statistician would want, that's going to make the whole fraction larger. When you divide by something smaller, it makes the overall fraction larger. And so again, we'll need a larger sample size. We try to get both of those going on, a high level of confidence and a low margin of error, each leading us towards concluding that we'll need a larger sample size. So there we go with the smaller margin of error, put in 3. Everything else is staying the same. Confidence level is still 95% in this part of the question. And we're still dealing with the standard deviation of 13.4. So what I'm changing here is the 3. 6 changes to 3 for the capital E margin of error. Round that up to 77 subjects. The fact that we have cut the margin of error in half, looking back at the formula, is going to make, when you divide by 1/2, that's going to make what's inside the whole fraction is 2 times larger. Squaring that, 2 squared is 4. So roughly, if we ignore the rounding that we did, this answer here, the 19.16 something, is getting multiplied by 4. Now we lose sight of that a little bit because of the rounding, but roughly this is 4 times bigger. That 77 is roughly 4 times bigger than the 20. So quadruple the sample size. And how many parts are there to this? This is just one last part. Okay, so increasing the confidence level. I'm also saying that this should lead to a larger sample size. Now we're talking about, we're back to, by the way, talking about the margin of error being 6 books. So 99% confidence level, 2.575 is our critical Z value. And we're back to dividing by 6. 2.575. Same standard deviation for the sample. Back to a margin of error of 6. And that's going to round up to 34. That, back in part A, that had a margin of error of 6. That answer of 34 is larger than that answer of 20. So increasing the level of confidence increases the sample size required because we've kept the margin of error the same. So let's see here. Greater confidence can be achieved with a larger sample size. Okay.